Hello, this is Peter So. Welcome to my video for the final project on Deep Azure at McKesson. My project will be covering a few key components on HDInsight. Here is the problem statement. Data volume is growing very fast in every organization. Storage cost is getting expensive. Scaling RDBMS systems are usually expensive and requires downtime. Users want reports in near real time and fast. So why I choose HDInsight? I'm very much interested to learn more about big data Hadoop ecosystem to research whether the problem statement that I have can be solved. In this project, I will discuss a few key components of Hadoop ecosystem, including HDFS, HIVE, and Zeppelin. I will also be covering Presto and Tableau for visualizing data from HIVE tables. Here's a brief summary of the project. I will start copying data files to HDFS, then create HIVE tables and run queries from Ambari. I will also demonstrate running queries from Presto and finally visualize the data from Zeppelin and Tableau. I will be using NPI data and US zip codes as sample data sets. Those data files will be copied into HDFS and reports will be created for visualization. So what is Hadoop? It's an open source platform, allows for distributed storage and process across multiple nodes. It can handle very large data sets on the cluster and use map-reduced programming model. Best of all, runs on commodity hardware. That doesn't mean it will be cheap, but it'll be a very reasonable cost compared to engineered systems. Here's an overview of the components from the Hadoop ecosystem. A few components to note are HDFS at the bottom, HIVE for SQL query, Ambari for managing the cluster, Uzi for workflow management, Scoop for data exchange. Example, data can be extracted from MySQL to Hadoop. Zookeeper to maintain and coordinate the processes within the cluster. Yarn stands for yet another resource negotiator, and there are many other components in the Hadoop ecosystem that is not covered in the scope of the project. I will focus on basic components like HDFS, HIVE, and Ambari in this project. I will be provisioning two HDInsight environments. One is for HDInsight Hadoop cluster and another one for interactive query cluster. The reason is Presto is only available in Hadoop cluster and Zeppelin is available on interactive query cluster. I'm not sure why HDInsight doesn't allow to mix some components of Hadoop on the same cluster. I will also be using Hortonworks HTTP sandbox to demonstrate Tableau with Presto. What is HDFS? It's Hadoop distributed file system. To save time, I will skip to explain all the details of HDFS as Google is our best friend. There are tons of information on the internet to learn more. So let's dive into demo to see in action. Let's see how easy it is to create HDInsight on Microsoft Azure. Click New. From the Data and Analytics, click HDInsight. Type in your cluster name and select the cluster type. Here, I'm going to be selecting Hadoop as one of the cluster type, and I will create another environment with interactive query. So for now, let's select Hadoop, and you can select Linux and click select. And then you have to provide the admin username, the password, and you can create a new resource group or pick up from the existing resource group. Select the location and click next. And in just a matter of 15 minutes, you should have HDInsight up and running. I have created two HDInsight clusters. Let's take a look into one of them. This cluster is created to demonstrate HIVE tables and Presto. If you look under script actions, Presto is already installed. The installation could be as easy as a few clicks. In this cluster, there are 6 nodes. Let's take a look into the other cluster. This cluster will be used to demonstrate Zeppelin. This cluster has 7 nodes. I have connected to the cluster. My sample files are under Final Project folder. And here's the command to display the files on HDFS. This is Ambari from HDInsight. From this dashboard, a lot of metrics could be monitored. As you see over here, the HDFS disk usage is only 7%. There are a lot of things that you can do from Ambari. I will jump straight to demonstrate HIVE. This is the query editor for HIVE. Let's take a look at the tables from here. The default database is selected. From here, you can select other projects. I have already created a few tables for the final project. I have providers table and the zip code tables. If you go back to the query editor, I have a few saved queries. The first query is to find the top provider counts by city. So you can type in your sequence over here and click execute. Now it's running. It takes a few seconds to run. So in this query, I am joining the providers table and the zip code tables based on the postal code. I'm going to group by the city and order by the top provider in descending order and retrieve only 10 records. So now the data is displayed right over here. This is how you execute queries in HIVE view from Ambari. Let's explore into Zeppelin. As you see on the screen, Zeppelin is a web-based notebook that enables interactive data analytics. You can make beautiful data-driven, interactive, collaborative document with SQL, encode, and even more. So let's take a look. To create a new notebook, create new note from here. I've already created a notebook for Final Project, so let's open that one. So the first HIVE SQL that I have is to show what databases are available. I have Final Project database created right over here. And the second one is to use this Final Project and show tables to display what tables are available in Final Project database. So the first interesting query is right over here. I have a SQL statement to find top 10 cities with most provider counts. As you see over here, the provider tables and the zip code tables are joined together with the postal code, and it will display the top 10 cities. So in order to run this, you just press Shift Enter. So let's make some changes. So the data is already displayed over here from the previous execution. So the data could be displayed in either table format or in charts. So let's change it to, let's say, 5. We only want to display the top 5 cities. So in order to run it, you just press Shift and Enter. So this is executing on the background. So while we're waiting, let's take a look at the other SQLs that we have already executed before. So this query basically lists out the top 5 states with most provider counts. So the data returned from the previous query, so it just displayed right over here. The results are displayed very nicely. And the last query that I have is to find for top providers by gender, only in California. So it's displayed in pie chart, or you can switch to display in bar chart as well. Pretty neat, isn't it? Let's start playing with Presto. In order to do that, let's connect to the shell. So from my HDInsight cluster, let's pick up the host name, and copy this, and go to the terminal window, and you paste that command to SSH into the cluster. Okay, so now I have connected to the cluster. In order to run Presto command line interface, say Presto dash schema default. Okay, so now I'm connected to Presto. I'm going to use final project. So let's run some queries. So here is the query to find the top 10 cities with most provider counts. As you see here, the results display pretty fast. If you compare the time it takes to run from HIVE Ambari view, Presto is pretty impressive. Let me refer to a few other queries that I have, and let's run it again. Pretty fast. Try one more. All the queries seems to be running pretty fast. Let's explore the last part of the project with Tableau. As you see over here, Tableau is a visualization tool that allows to connect various data sources. As you see over here, it can connect to Excel, to MySQL, Oracle, and Presto is one of the data sources that Tableau can connect to. Let's create a new Tableau workbook. My data source is from HIVE tables. I have selected the final project database, and I have 2 tables over here, and they are joining together by zip code. So the join type is inner join, as you see over here, inner join, and then by the zip code. So let's take a look at the sheet one. Let's create something. Let's create a report of top 10 providers by city. So in order to do that, just drag the city to rows, and let's drag the number of records to the columns. All right, so now the data displays. But we only want to get top 10, so let's filter it out. Drag the city to the filters, and let's say top by field, top 10. All right, so let's sort this. All right, this is what we get. Let's create a new one. This time, let's do something more interesting. Let's drag the state to rows, and the query executing. So let's take a look on the background on the cluster overview. As you see, the query is running. Oops, now it's finished. Let's take a look. All right, and let's bring up the number records to columns. Let's take a look on the cluster. It's running. All right, it's finished. Okay, this is what we get. But we want to display the states on a map. So let's click the map type over here. All of a sudden, you get the United States map with different colors. Let's zoom up a little bit. And let's move it to this side. All right, so let's change the colors of the states. So you can pick from this. Let's pick this one. So as you see here, the states will have different colors depending on which states have more providers. Let's add some the number of records to each of the states. So let's drag this up to the label. Then you will see how many providers are in each state. Okay, let's filter something. We want to see only the providers from a few states. So let's drag state column, filter it. Let's unselect all, and let's say we pick from California, we pick from New York, and let's say we pick from Texas. Click OK, and this is what we get. Right, let's unhide this one, make it bigger. All right. From the background, as you see, there are a series of queries executed on the cluster. You can monitor how each of them executed. This is the end of the demonstration for my project. Thank you for watching.